Today we're going to be going over the troubleshooting a hot water heater, as well as what the process is for a hot water heater to work. Here you have your pressure relief valve. You want to make sure that it is inserted correctly, not cross-threaded, and also make sure that you have your Teflon tape on there. Make sure it's inserted snugly, and the other thing about a pressure relief valve is that a pressure relief valve will release at 110 degrees when it reaches 110 degrees, or at 150 psi. So anytime one of those two things happens, this will open up and dump out the pressure and the water. We come down to here. Here's our upper thermostat and our upper heating element. You should have 240 coming in here. We will go through this in a diagram a little later, but the power comes in starting here. Anytime you're troubleshooting your coils or your heating element, you want to make sure that the power's off, and you want to disconnect both your wires. Then you will take your field piece, and you want to check that you're getting continuity on your element. We're getting continuity there. If you do not get continuity, you have a burnt heating element. Another thing you can do is touch to the metal here. If you hear a buzz there, then you know you have a short inside. You want to check both of those, and if you get continuity between any of these two and the metal of the tank, then you have a short. You got to replace that. Down here we have the lower heating element. Again, same thing, disconnect power, and you want to remove the wires, check to the tank, check that's a good element. As far as the lower thermostat, a lot of times you'll find a hot water heater that you have to push the reset. Anytime you hit that reset, more than likely it's the bottom thermostat that is either bad, or you may have a loose connection somewhere causing that to trip. So anytime you're having to push that reset, you want to make sure that you're checking your wires, that you have good solid contact and they're not loose, because if it's jumping around, that will also cause that lower thermostat to trip that. As far as checking your thermostats, there's no real way to check to see if they're any good, but anytime you have a problem and it's this lower one and you're having to push that, more than likely it's that lower thermostat. If you're not getting anything anywhere, then you might go ahead and replace your upper thermostat. Whenever you put it all back together, make sure your insulation is on there, make sure your covers are on good. Here we have a hot water heater that was donated by Parts Master so that we could cut a section out of it. As you can see, it's been dropped a time or two. We cut this section out so that everybody could get an idea of what is inside of a hot water heater. Real quick, we'll go over what we have here. Closest to us, we have the sacrificial rod. This is aluminum. It does its job by sacrificing itself. Over here we have the blue dip tube. Your cold water comes in the dip tube and fills the bottom of the tank. That way the heated water pushes up to the top and out your hot outlet. We have our upper heat element and our lower heat element. They do not come on at the same time. They alternate as needed in order to keep that water heated. But again, your cold water comes in the dip tube. If your dip tube breaks off or disintegrates, then you're going to be dumping cold water in the top, and that's going to cause, you will not have any hot water going into the apartment. Pretty simple. Up here you can see all the connections, and you should see that our pressure relief valve is up in here. But other than that, there's not a whole lot inside a hot water heater. A couple of things I'd like to also discuss or talk about is the your insulation on this particular unit. There's about 1.5 inches of foam insulation. One of the other common problems we see on a lot of our properties is the buildup of calcium at the bottom of your tank. Some of you probably seen this before. You go to open your drain line and it just kind of oozes out. What happens is the calcium starts building up in here, and once it gets up to that heat element, a lot of times that's when you're going to lose that bottom heat element, is just because it's getting crowded by the calcium buildup. It is a good idea to drain these, yearly. I realize in our industry that's not very feasible, but if you do want to keep the calcium levels down, flush it out once a year, and that will help eliminate that problem. I hope that this has been informative. We'll be doing more videos on different things, and we'll probably get better at it. That's all we got for now.